Today we'll talk about a new topic that is calculation of average value of any function. Actually, in physics, there are several equations will come, several functions will come where we have to calculate the average value. So let's start. Average value calculation. Average value calculation. So the rule is the average value of any function f of x in the interval a to b is, now we can write or we can represent average by using this notation. We can give a bar symbol or we can write this f of x in this way. These also represent average value. So the formula is a to b f of x dx divided by a to b dx. So this is the rule that you have to remember, that the average value of any function f of x in the interval a to b is basically, you have to integrate the function f of x from a to b with respect to dx with respect to x, and then you have to divide this thing a to b dx. Okay, this is the rule. The average value of any function f of x. Now this function is f of x, so it depends here, f depends on x. That is why we are integrating with respect to x. If there is a function which is function of y, then we have to integrate with respect to y. If it is a function which depend on t, then we have to integrate with respect to t. That's it, nothing more, nothing less. So now how we will calculate? Let us see the average value of sine function. Actually, we all know half cycle means 0 to pi and full cycle means 0 to 2 pi. I think we all knew that 0 to 2 pi means full cycle and 0 to pi means half cycle. So first we will calculate the average value of sine function. Average value of sine function. How we will calculate it? Let us see. Let f of x equal to sine x. Now its average value in full cycle. In full cycle, that means average of f of x in full cycle means 0 to 2 pi. Here sine x dx divided by 0 to 2 pi dx. So according to the rule, if we integrate sine x, we will got minus cos x. So minus cos x, and then we have to use the limit 0 to 2 pi and divided by 0 to 2 pi. If you integrate dx, then you will got x. So the value is minus, if you use the limit cos 2 pi minus cos 0 divided by 2 pi. So cos 2 pi is basically 1 and cos 0 is also 1. So the value is minus 1 divided by 2 pi. So the entire thing will become 0. So what we just see, that the average value of sine x or sine function in full cycle is 0. The average value of sine x or sine function in full cycle is 0. So just imagine that what will be the average value of cosine function in full cycle. Let us calculate the average value of cosine function in full cycle. So then we will consider f of x is equal to cos x, and we will use the same rule. So here it will be cos x. So if you integrate cos x, the result will be sin x and the denominator will not change. So the value will be sin 2 pi minus sin 0. So here the value will be 0 because sin 2 pi is also 0 and sin 0 is also 0. So what we just see, that the average value of sine function and cosine function, that means sin x or sin y or sin z or sin t, anything, or cos z or cos t or cos y, anything, the average value of sine or cosine function in full cycle means 0 to 2 pi is equal to 0. Now what will be their values in full cycle when you will take the square of those functions? That means what will be the value of sine square function in full cycle? So let f of x is equal to sine square x. So in full cycle, now its value will be, so average of f of x is equal to 0 to 2 pi sine square x dx divided by 0 to 2 pi dx. Just see, we are using the same formula because this is the general formula for calculating, average value. So that is why we are using same formula. Just we change the function, because first we take the average value of sine function, then we take the average of cosine function. Now we are taking the average of sine square function. Similarly, you can take the average of cos square function also. So now what it will be? It will be 0 to 2 pi. So the denominator will be 1 by 2 pi and 0 to 2 pi sine square x dx. Now there is no direct formula for the integration of sine square x. That is why you have to use a little formula. What was the formula? We know cos 2 theta is equal to, we all know cos 2 theta is equal to cos square theta minus sine square theta. So we can also write it 1 minus sine square theta minus sine square theta. So the value will be 1 minus 2 sine square theta, that is basically cos 2 theta. Now we can write 2 sine square theta is equal to 1 minus cos 2 theta. Just see here, we know cos 2 theta equal to cos square theta minus sine square theta. Cos 2 theta equal to cos square theta minus sine square theta. So here instead of cos square theta we can write 1 minus sine square theta. So now by arranging all this value we can write that sine square theta equal to half of 1 minus cos 2 theta. Sine square theta equal to half of 1 minus cos 2 theta. So now similarly we can write here that 1 by 2 pi, and here we will write 0 to 2 pi half of 1 minus cos 2x into dx. So it will be 1 by 4 pi, now 0 to 2 pi 1 minus cos 2x into dx. This half and this 2 pi becomes 4 pi. Now we can wrap the upper part. So the value will be average of sine square x is equal to 1 by 4 pi. Now we can write it in this way, 0 to 2 pi dx minus 0 to 2 pi cos 2x dx. So it will be 1 by 2 pi, 1 by 4 pi into, that will give you 2 pi minus, just see, this is the average value. This is basically the formula for average value of cos function, because when you will take the average value of cos function, then in full cycle, then the numerator will looks like that. So if you just integrate that one and putting the values of limit, then you will got 0. How? Just see here. So if you integrate this thing, so you will got cos 2x means sin 2x divided by 2. So 0 to 2 pi will be the limit. So now we can wrap the below part. So 1 by 4 pi into 2 pi minus 1 by 2, if you put the limit, sin 4 pi minus sin 0. So that is 0, the entire thing becomes 0. So 1 by 4 pi into 2 pi minus entire 0, so 1 by 2. So the average value of sine square function is in full cycle is 0. In half. The average value of sine square function in full cycle is half, and the average value of sine function in full cycle, that was 0. So now it will be better if you calculate by yourself the average value of cos square function by using the same procedure in full cycle, then the result that you will got will also be half. So now in conclusion we can write that the average value of sine and cosine function in full cycle, that means 0 to 2 pi, is always 0. And the average value of sine square and cosine square functions in full cycle is half. Now the interesting thing, that where we will use all these concepts in physics, we will use this concept in several places, just like for class 12 alternating current. The question may be, they may be ask you that question, that given current I is given, I equal to 4 plus sine 10 pi t ampere. So calculate the RMS value of current. Now we all know RMS current means IRMS. So RMS means root means square. So what we have to do I square, then its average, and then its root. This root square, first you have to take the square, then take mean, and then the root. So IRMS square equal to I square average. So now I square means 16 plus sine square 10 pi t plus 8 sine 10 pi t. This is the easiest rule. So now IRMS square becomes average of 16 plus sine square 10 pi t plus 8 sine 10 pi t. So 16 is a constant, so its average value is also 16. So here sine square, this is basically sine square function. So when you will take the average of sine square, so that will become half. And now the question, now one thing that will arise here, that in full cycle or half cycle, actually when we are not talking, we don't mention that in full cycle or half cycle, we just only ask you that find the RMS value of current. So in general, if in the question they don't mention, then you have to take the average value in full cycle. If they mention, that is another thing. That if they mention that calculate the value in half cycle, this is another thing. But if they don't mention anything, then you have to calculate its value in full cycle. So now 8 is constant, 8 will come out. So the factor will be sine 10 pi t. So that will be 16 plus 0.5. And it will be 8 into 0, because the average value of sine function in full cycle is 0. So the answer will be, that will looks like that this is IRMS square basically. So IRMS square is basically 16 plus half, so 2 is the LCM, so 32 plus 1, so 33 by 2. So IRMS is basically root over 33 upon 2. This is basically the RMS value of current. Similarly, you can find the RMS value of voltage or RMS value of current for any quantity, for any equations. Now, in class 12, that thing also arises. In simple harmonic motion, we all know that let the displacement of a particle is given by x equal to a sine omega t. So that particle will definitely execute SHM, because when the displacement of a particle is represented by this way, so then if you take the differentiation, then definitely that will satisfy the general form of simple harmonic motion. So now if you take the differentiation dx dt, that will be v, speed of the particle, a omega cos omega t. So the kinetic energy of the particle will be half mv square. So it will be half m square omega square cos square omega t. So this is basically Ek, kinetic energy. So what is the maximum value of kinetic energy here? To get the maximum value of kinetic energy, you have to use the maximum value of cos function, and we know that the maximum value of cos function as well as sine function is 1. So maximum kinetic energy is half m omega square square, half m omega square square, sorry, half m omega square square. Now what will be the average value of kinetic energy? So the average value of kinetic energy will be half m omega square square into cos square omega t. So it will be half m omega square square, that will become outside the average notation. So there will be half m omega square square into half. If you take the average value of cos square function, then the value will be half. So that will be 1 by 4 m omega square square. So this is the average value of kinetic energy, and this is the maximum value of kinetic energy. If you see carefully, then you will be able to establish that relation, that basically average kinetic energy is equal to half of m omega square square. That means half of maximum kinetic energy. Average kinetic energy is basically half of maximum kinetic energy, and that result is very useful for simple harmonic motion. Similarly, one can calculate the relation of potential energy. As I told just that let the displacement of a particle executing SHM is given by x equal to a sine omega t. So its potential energy, where we consider that m was the mass of the particle, so its potential energy EP will be half m omega square square sine square omega t. Because we know that the formula for potential energy is basically half k x square, and k is basically m omega square. Okay, k is basically m omega square. So now we can write the maximum value of potential energy is basically, to get the maximum value you have to use the maximum value of sine function, and that is basically 1. So half m omega square square, and similarly the average value of potential energy is basically half m omega square square into average of sine square omega t. We just see that the average values of sine square function as well as cos square function in full cycle is always half. So it will also be 1 by 4 m omega square square, and we can find this relation also, that average of potential energy is equal to half of maximum potential energy. So that result is very useful. So we will solve one numerical on the basis of that thing. So the numerical is for a, just write the question, for a particle of mass 2 gram executing SHM, simple harmonic motion, its total energy is 10 joule and minimum potential energy is 2 joule. Find the average kinetic energy of the particle. So now here we can write, we know that total energy is basically sum of kinetic energy plus potential energy, and here they say that the potential energy is minimum. So when we know that total energy is always conserved, that means the sum of kinetic energy and potential energy will always be constant. So when we will use the minimum value of potential energy, then automatically kinetic energy will become maximum, because their sum should be constant. The sum of potential energy and kinetic energy should be constant. So if one reaches its minimum value, definitely another one will reach its maximum value. So we can write here E equal to Ek max plus EP mean. So in question if you use this data, then we'll got 10 equal to Ek max plus 2, that is minimum potential energy. So here the maximum kinetic energy is basically 10 minus 2, that is 8 joule. So maximum kinetic energy is 8 joule, but in the question they ask you to find the average kinetic energy. Now we know, since average kinetic energy is equal to half of maximum kinetic energy, so we can write the average kinetic energy will be half of 8, so that will be 4. So the average kinetic energy will be 4 joule. Okay, and you can also expect that thing in your board exam, that show that in full cycle the average value of kinetic energy as well as the average value of potential energy for a particle executing SHM, it is always valid. For a particle executing SHM, its average value of kinetic energy is always equal to the average value of potential energy. Another one thing, if you notice, then we will be able to see that this is the last thing that I will discuss today, that for a particle executing SHM, in general its kinetic energy is basically half m omega square a square cos square omega t, if its displacement is denoted by x equal to a sine omega t, then that will be its kinetic energy, and potential energy will be half m omega square a square sine square omega t. So definitely the total energy E will be sum of kinetic energy and potential energy half of m omega square a square. Now the funny thing is, if you take the average kinetic energy, that will be 1 by 4 m omega square a square, and average potential energy, we just see that is also 1 by 4 m omega square a square. So now if you add this average kinetic energy plus average potential energy, then what you will got? The result is half of m omega square a square plus, sorry, half not, 1 by 4 m omega square a square. So the result will also be half of m omega square a square. So this is also total energy. So if you normally add kinetic energy plus potential energy for a particle executing SHM, it will be equal to the total energy, and if you add the average values of kinetic energy and potential energy for a particle executing SHM, then you will also got the value of total energy. So for today, that's it. You have to remember these things carefully. That's it.